In this lesson, we are looking at the MVP curriculum for Math 2, Unit 6, Lesson 6, Let's Make a Function. In this lesson, we are going to be using all that we've learned about radical and inverse functions and transformations to write the equation of a transform function given a graph. And we're looking at the square root function, y equals the square root of x, or the inverse variation function, y equals 1 over x. And we're deciding what transformations have occurred. So in the first two examples that I have here, these are square root functions. So they begin with the equation y equals the square root of x. And then what we're going to do here is we're going to decide what type of movements occurred. So we need to think about what our parent function looks like here. And our parent function for a square root is going to begin at 0, 0. And then we're going to go 1, 1, 4, 2. The square root of 1 is 1, and the square root of 4 is 2. And I just noticed I put both of those points at the wrong place. Well, let me fix that real fast. Alright, so 0, 0, 1, 1, and 4, 2. There we go. Okay, so if we're looking at this, we can see that there is a shift towards the left 2 units. And if we go here, if I start at that end point of -2, 0, if I go over 1 and up 1, I'm keeping the same scale. If I go over 4, we also go over 4 and up 2. So that means there's no stretching or compressing that has occurred here. We just simply moved over 2 to the left. So if you recall, that's going to go under our radical. And when we move left and right under the radical, we have to have the opposite sign, because what's actually moving is our axis and not our individual point. The next one, if we look at it, again, we're going to have those same starting points, 0, 0, 1, 1, and 4, 2. And if we look here, we can see a downward movement to what appears to be -5, 0. And if I go over 1, up 1, over 4, up 2, I can tell that there's no vertical stretch or compression. So I just moved, in this case, down 5. So recall that that's going to be a change outside the parenthesis or the radical. So this is going to be the square root of x minus 5, since we moved down 5 units. All right. The next two that we're going to look at are inverse functions, inverse variations. So this is y equals 1 over x as the parent for both of these. So when we think about this parent function, we need to recall what it's going to look like. And this one has the horizontal asymptotes at y equals 0 and x equals 0. And then it goes over 1, up 1. We have 2 would be 1/2. And then 1/2 would be at 2. And that would be true on the opposite side, -1, -1, -1/2, -2, and -2, -1/2. So those are the points that we're going to look at on each of our two graphs. So I'm going to go ahead and get all those points sketched in here. Alright, so what we have is we can see that our horizontal and vertical asymptotes have shifted. And the best thing to do here is to kind of sketch those in. We know that we don't want to cross that horizontal and vertical line that is existing there. And if you see, it appears that it's approaching a downward shift of 3 and a right shift of 1. So what we can say here for our equation is that we moved right 1. So that's going to go in the denominator with x, and it's going to be a negative. And we moved down 3, and that's going to be outside of the function. So this is showing that double movement. The next one, we have also a upward movement of 1, and we have a leftward movement of 4. So that means under the radical, or under the 1 in our denominator, we're going to have a plus 4 since we moved to the left, and we're going to have a plus 1 outside showing that upward movement. So these types of transformations were vertical and horizontal shifts. Vertical and horizontal shifts. Alright, so let's look at the next few. Here we have some square root functions. So we're going to have our parent function of y equals the square root of x for each of these. And if you notice, the first 3 of these all begin at 0, 0. Their big differences is in their orientation around that axis. So let's again think about what our original is going to look like. 0, 0, 1, 1, and 4, 2 for all of these. So I'm going to get all that put in, or as much as we can see. Okay, so on the first one, if you look, it appears that it just reflected over the x-axis. So in order for that to happen, we just need to have a negative in the front of our function. The second one reflected over the y-axis. That means that our negative is going to exist underneath the radical with the x. So this is a square root of negative x. The following one appears to have flipped twice. It has flipped over the x-axis and the y. So I'm going to imagine it flipping first over the y. So I would have a dot of 1 over 1 and then over 4 and up 2. And then I did the exact same flip, but I went over the x-axis this time. So this means I have a negative outside the radical as well as inside the radical. The third one here has flipped. It appears over the x-axis, so that means I'm going to have a negative out. But in addition to that, if I were at 1, negative 1, and 4, negative 2, I've also done some shifting left and down. So I've moved over left 2 units, and I've moved down 3 units. So a leftward movement is going to be a positive 2, and then a downward 3 will get me that new equation for that function. Let's now look at some inverse functions here. These parents are going to be 1 over x. Let's again think about what the parent function's original order pairs were. And at 1/2, it was at 2. And then at 1, 1. Same thing mirrored on the in the quadrant 3, 1, 1, or negative 1, negative 1, negative 1/2, negative 2, and negative 2, negative 1/2. I'm going to plot those same points on this other graph really quickly. Okay, so if you look here, this is reflected and shifted. So I'm going to put a negative in the front because now the piece above the x-axis has shifted or is on the other side of the y-axis now. And this whole thing has shifted over to the left 5 units. It has not moved up or down. So underneath with that x in our denominator, I'm going to put a plus 5 to represent that horizontal shift left. The next one has also been reflected, but this one has shifted twice. It has shifted 3 units right and 2 units up, so I'm going to put negative. And then in my denominator, I'm going to put -3 for my right units and +2 for my up movements. So the big comparison in 9 through 16 is that these functions have reflected. Now with the square root function, when we had a negative x inside, that was a y-axis reflection. When we had a negative outside, that was the x-axis. With the inverse, just a negative is all that's needed because either way it's going to do the same type of reflection. Okay, so now we have another type of transformation. Again, we're starting with some square root functions. Okay, and here you should notice that these are looking a little thinner and wider. Again, I'm plotting my parent points. And when I look at these, instead of going over 1 and up 1, we are now going over 1, up 3. And instead of going over 4 and up 2, we're going over 4 and up 6. So if I think about 1, 1, and 4, 2, and then 1, 3, and 4, 6, I can see that my y values have been multiplied by 3. So I'm going to take my function and I'm going to multiply it by 3, and that will give me my new function. So that is a vertical stretch by a factor of 3. The next one, if I plot my points again, 1, 1, and 4, 2, this time I see that my points are lower. Instead of going over 1 up 1, I'm going over 1 up a half and over 4 up 1. So my original ordered pairs were 1, 1, and 4, 2. And now they are 4, 1, and 1, 1 half. So this time I'm noticing that I'm going to multiply by a scale factor of 1 half. This is a vertical compression by a factor of 1 half. The next two are inverse functions. These are sometimes a little harder to see, but we're going to look at some techniques that will hopefully help you in recognizing a transformation here. Okay, so again, we're going to plot our original pieces 1, 1, 1 half, 2, and 2, 1 half. And we'll do that on both sides, or both quadrant 1 and 3. And what we can see is that now we're going at 2, we're going to a different point here. We're going to 2 and 1.5. At 1, we're now at 1 and 3. And at 1 half, we're now at what appears to be potentially 5.5. As you may be able to see, these points are kind of difficult to determine what our actual movement is. So another way to look for this movement is to look at any whole number ordered pairs that you can find. So I see 6 and 1 half. I see a 3, 1. I see a 1, 3. So if I think about that, when my x is 1, my y value is 3. The only way that that's going to happen is to say 3 divided by 1. If I do that with 3, if I say 3 divided by 3, then I get 1, which is that ordered pair from before. 3, 1. And then if I were to do 6 divided by 3, that would be 1 half, which is what I got or excuse me, I reversed that one. 3 divided by 6. If I do 3 divided by 6, that is that 6 1/2. So what's happening here is that our numerator, instead of being a 1, our numerator in this case is going to be a 3 over whatever our x is. Now the next one, let's do the same thing. So let's plot our original points of 1, 1, 2, 1/2, and 1/2, 2. And here we can see that it's compressing down. So we would expect a fraction here. And if we look again for some nicer to read ordered pairs, we can see one at 1/2 1. We can see that's probably about it, actually. Looking at this, there's not a lot of pleasant ordered pairs here. So I went from 1, 1 to 1/2, 1/2, which means I would expect that I divided by a half, everything reduced by 1/2. So that means that that function would be 1/2 x, with the x in the denominator with the 2. Now, these were dilations. The effect is that when a that we're multiplying by is greater than 1, we have a vertical stretch. And when a is between 0 and 1, and that's the absolute value of a, is between 0 and 1, we have a vertical compression. All right, so the last problem is combining everything. So let's look at these. The first one is a square root function. You should notice that it has been reflected. All right, this has been reflected over the x-axis, which means our negative sign is going to be out front. You should notice a shift to the left 3 units, which means we're going to say plus 3 inside the radical. And then we have moved down 1 unit, which means we're going to have a minus 1 outside the radical. We do need to check for any stretching. So what we're going to do is make some points using our pattern. So 0, 0, we're going to imagine would be that original point. And then we would expect to go over 1 and up 1, in this case down 1, over 4 and down 2, going down because I reflected. You should notice that that is not the case of what's happening here. So we're going to figure out what is happening and mirror that up above. So I'm going, instead of going over 1 and up 1, I'm going over 1 and up 2. And then it went over 4 and up 4, which meant that we were multiplying everything by 2. So I'm going to come over to my function, and this is going to end up being a y equals -2 times the square root of x plus 3 minus 1. The last one is an inverse function, and that has not been reflected. It has, however, shifted down. It has shifted down 2 units, and it has shifted right, it appears, about 1 unit. So, or left 1 unit, excuse me. So that would be a function of 1 over x plus 1 minus 2. And now we just need to check for any stretching that may have occurred. So I know if that's my new origin, I should go over 1, up 1, over a half, up 2, and over 2, up a half. That is not what I've done. Instead, I have a, it appears that I've gone over 1, up 3. So if I've gone over 1 up 3, then I've multiplied by 3. So that means that my numerator is going to become a 3. And my problem becomes 3 over x plus 1 minus 2. That concludes this lesson.